Hi everybody, John here for Math 186. This is the first video, and so I'm going to explain a little bit about how these videos work. I'm going to go through the lecture notes that are posted on Blackboard and work through the examples. You can pause, rewind, rewatch these as many times as you need to before going on to Pearson MyLab and doing the assignments. We are going to start here with graphs of equations, section 1.1. All the videos will be 15 minutes or less because that's the time limit on YouTube, and so I will be uploading these there, and therefore if we're running out of time I will be picking up on a topic in the next video. So I'll put them in a playlist for you to see. So graphs of equations, this is the first section, and what we're really interested in here in the first half of this course is just making sure we have all the skills down that we're going to need if we take calculus, which this is called pre-calculus because we're just trying to get our algebra skills good enough for calculus. So we're going to start with the coordinate plane. So things that you need to know about the coordinate plane. Well, this is how we would label any graph that we come across. We would label the x-axis, we would label the y-axis, and then we would need a scale. Now here every box is labeled, every line in the horizontal direction is labeled 1, 2, 3, 4, 5, and so on in the left direction, -1 and -2. But if I just put a 1 here and a 1 here, that would be sufficient, because that tells me that this length right here is 1 unit, which means that any length that is that same distance is also 1 unit. And so I need a scale in that vertical direction. But just because this is 1 unit doesn't mean that this is 1 unit. And so I also need to label the x-axis so that I know how far I'm going horizontally when I label a graph. So we need a scale in both the x and the y direction. It is best practice to label all of the graph, but if you have a very large graph or a very short amount of time, you can just label 1 unit in each direction so that we know how much each box is worth. It doesn't have to be 1 unit. You can label 1 box in each direction so we know how much that 1 box is worth. So when I go to graph these points, let's talk about the coordinate plane. It's important to know that this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. And this is going to become very important later on in this course when we start talking about trigonometry. Knowing which quadrant is which and what sign the coordinates take on in each quadrant. For example, this first point, -2, 4, a negative x coordinate, this is the x coordinate, this is the y coordinate. A negative x coordinate suggests that I move to the left here and up 4. So here's my point. Okay, now we don't really need to draw all of this stuff in as we go. So we're just plotting our point right here. This is -2, 4. Notice that in the second quadrant, x coordinates are negative and y coordinates are positive. The next point, 0, 4, is actually right here. This is not a quadrant. This is actually the y-axis. So that is not considered a quadrant. It is an axis. We have the point 1, 2, so I go to the right 1, up 2. This is in the first quadrant. In the first quadrant, both x and y coordinates are positive. 2, -4 is 2 to the right, down 4. That brings me here. In the fourth quadrant, x coordinates are positive and y coordinates are negative. And finally, we have -3, -2, so 3 to the left, 2 down. Here we are. And in the third quadrant, both the x and the y coordinates are negative. Now I know you might all know this already, but it's just really important to have a good grasp on which quadrants are which and which coordinates are positive or negative in each quadrant. Let's move on. So now we're going to find the distance formula. We're going to use the distance formula to find the distance between 2 points on a coordinate plane. Now, if you can't remember this formula, an easy way to remember it is that it's derived from the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. And in that situation, we are referring to a coordinate plane. And that coordinate plane, or we're actually referring to a triangle, where this is A, this is B, and this is C. And as long as it's a right triangle, this is true. So the distance between 2 points, let's just go back to this previous slide here and look at these 2 points right here. Okay, how about this point and this point? And I want to find the distance between them. If I want to find the distance between them, I can draw a straight line between them. But what you realize is that this straight line can be thought of as the hypotenuse of a right triangle. Here is the right triangle right there. And so the distance formula is really the hypotenuse of a right triangle. It's this end. If this is A and this is B, this distance right here is actually just the distance between the x coordinates. This is x, let's call this x1, let's call this x2. So this distance right here is x2 minus x1. It's -3 minus -2, which is 1, positive 1. The distance between them, okay? Or it's the absolute value, because this is distance, not displacement. And then you can see right here that B is this distance right here, which is, if this is y1 and this is y2, this is y2 minus y1, this distance right here, absolute value-wise. And so, going back to the Pythagorean theorem, what we get here is A is the difference in the x values, but I'm squaring it. And so the absolute value is not necessary because when I square anything, it comes out positive. The distance in the y values is my b. Again, I'm squaring it, so the absolute value wasn't necessary. And that gives me the distance squared between the 2 points. So if I just want to find the distance, I square root both sides, and I end up with that formula. So we want to find the distance between the points -2, 4, and 1, 2. So again, we can think of our coordinate plane, and I just want to do a quick sketch here, nothing too fancy. So if you don't have graph paper, you can always just make your own graph on a piece of paper. So -2, 4 is the one that's up here. We just did that one. And 1, 2 would be right here. And we don't really know that until I label the y-axis scale and the x-axis scale. But this is -2, 4, and this is 1, 2. And we're looking for this distance between them. Do this in red. So we're looking for, that wasn't so good, we're looking for this distance right here. So how we're going to find that is we're actually going to figure out, well, what's the difference between the y coordinates, what's the difference between the x coordinates, and we can use those to find the hypotenuse of this right triangle. So we're going to use the distance formula. So the distance formula is the square root of the difference between the x values. So let's do 1 minus -2 squared plus the difference in the y values. Now typically we want to stay consistent here, but it doesn't actually matter which order I do this in. But since I did do 1 minus -2, I should probably do 2 minus 4. It's going to be squared, so it's going to come out positive anyway. 1 minus -2 is 3, squared gives me 9, plus -2 squared gives me 4, and this is still in a square root, and so the distance between these 2 points is the square root of 13. Now since 13 is a prime number, it cannot be broken down into smaller parts, and so this is as reduced as I would get. Okay, so we will pick up here in the next video, but again, feel free to rewatch this as many times as you need until you understand the content. Then you can go on to Pearson MyLab, do the study plan, and I would go under the prerequisite tab, because there I've already outlined all the skills that you would need to complete the problem set for this week. So if you wanted to stop at this video and just do that prerequisite knowledge, which would be finding the distance between 2 points, you could do that. There's also one on just the coordinate plane, so you can do that as well. And then those are the skills that you're going to need to be successful on the problem set. Now the problem set you can do as many times as you want up until the due date, but when I say that, it's not like you can do a problem as many times as you want. You do the whole problem set, and then you could start over if you wanted to. Okay? I will see you in the next video.